Welcome to another video of engineering materials. This video is the part 2 of the lecture phase diagram. So let's begin. We'll be starting with binary eutectic system. So we're discussing the eutectic points and the eutectic reactions. So here you can see that this is again their time temperature phase diagram, which you can see that is percentage of solvent that is freezing and the percentage of solute is solvent, the solute is dissolving in the solvent. So at 0% of the solute, that sharp freezing point. However, while we reach the percentage of the solute, the purity of the substance is compromised, and therefore that the freezing point is not constant over there. So we have this phase diagram in which the percentage of the solute. Here you can see that we have a lot of phases. This phase is the liquid phase, and so when cool down the liquid around percentage, you see that we have two phases over here. This is the liquid time, and we have two phases over here. One is the alpha phase, with the A phase, solid, with the solid, and with that we have the liquid as well. So after further cooling that, we are getting here A plus B, which is all solid. So if we are looking to the right side, you can see that cooler from this side. So we are getting phase B, which is solid as well, plus the liquid, which is the metastable state. So this state and this state is the metastable phases, and if we cool it down further, so again we will be getting A plus B, which is all solid. Okay, so we'll be discussing this type of eutectic system a lot in this lecture. And let's look at this one. This is the point. This is called the eutectic point. At this point, this liquid is directly converting to two solids, A plus B. So this point, the composition at this point is called the eutectic composition, and the temperature at this point will be known as the eutectic temperature. Okay? So this is the eutectic point, and the system will be called the eutectic system. Okay, so let's see this. We have this system of silver and copper. Copper is the solvent over here, and we have silver as the solute. You see that the percentage of silver is being increasing, and over here you can see that this area is the liquid area, which this line with the liquidest line, and this line is the solidest line. Okay? So while we cool down the liquid at 71.9% of silver, you can see that the whole liquid is converting into this alpha and beta phase. Okay, so how do we know that this phase is alpha and beta? So we'll be also discussing into that. First of all, let's discuss over here that if the percentage of silver is nil, so while there will be only copper. So while we will be cooling down the copper, we will be getting this alpha directly from the liquid phase. And if we have 100% of the silver and no copper, so we will be getting, while cooling, we will be getting this beta phase. Okay, so these are the original two phases, which are alpha phase and the beta phase. Okay, Now if we are cooling it around somewhere here, we're reducing the temperature from around 1200 to 900 degrees centigrade. So we'll be getting a metastable state, a phase which has alpha plus the liquid. So the alpha would be coming from this side and the liquid would be coming from this side. Okay. So this state is called now the metastable state is alpha plus liquid. Okay. And if we cool it down from 80%, around 80% silver, from around 1200 degrees centigrade, we'll be getting the beta phase and the liquid. Okay, because we have beta over here and we have liquid over here. And, okay, so this state will be again the metastable state of solid and liquid and beta and alpha. So now if we are cooling it down from around 71.9% of silver, we are getting directly alpha plus beta. We are going at the eutectic composition. We are pulling it down from the eutectic composition, which is 79.9% of silver and the rest is copper. Okay. However, if we cool it down from here, this side, which is a 30%, around 30% silver, still we are getting alpha plus beta from this side. First, we'll be getting alpha plus liquid, and then again we'll be getting alpha plus beta. Moreover, we'll be getting here cooling it down from the right side of the eutectic line. Again, we'll be getting this alpha plus beta phase, but there must be some differences. So, what are these differences that we are going to study? I'll mark this mark eutectic. This is the straight line, but this is the eutectic line. Okay. So what are we going to do is we are going to calculate the amount of phases present from the level rule, and also we'll be discussing the microscopic changes while cooling from the liquid region on a eutectic line, and the hypoeutectic and the hypereutectic phases as well, which is this region is the hypoeutectic region and this region is the hypereutectic. Hyper means more and hypo means less. So this region will be the hypoeutectic region and this will be the hypereutectic. So we'll be discussing it all. Okay. So we have a two-component system. It's a binary eutectic system and a special composition with the minimum melting temperature T. Okay. So T is the melting temperature. Again, we have this copper and silver solid solution. So this region, the green region you can see is all the liquid, and this is the eutectic composition around eutectic temperature. So we have three phases over here. We have an alpha phase, we have a beta phase, and we have a liquid phase. Okay, and we can see the solid solubilities of alpha is mostly copper, but not all. It's mostly copper. You should not be mistaken that this is alpha region is copper only. No, it's not copper only, but it's mostly copper. There must be some amount of silver present as well. And in the beta region, there will be mostly it would be silver, but not all again. As you can see, the region is over here, which is not 100% of the silver. And the alpha region is just in here as well, which is not 100% copper too. Okay, so it is mostly copper and silver. Okay, so now T is the effective temperature, it's the composition. Okay, the effective reaction is that a liquid have this composition will be converted into alpha and alpha region that will be getting, okay, and the liquid will directly be converted from into alpha. And the liquid here consists of 71.9% of silver, will be directly converting into 8.01% of silver and 91.2% of silver. Okay. We can calculate this from the middle rule. So now here will be the most important part in discussing the microstructural changes in the hypoeutectic and the hypereutectic. Okay. So we go ahead and this is again the liquid thing. We are just discussing this area of the hypoeutectic. Okay, we have shown to them. So while heating from 400 degrees centigrade, you can see that this is all liquid now because it's the inner region, all liquid. And once we are cooling it down, we know that the alpha particles are mutating and further it will be growing directly into the solid as it is directly converting into solution. Just a smaller gap, but it won't be much of a worry. But then directly growing into a second phase, that is alpha phase. This is a polycrystalline with grains of alpha phase having components around 2% of 10. So this is let 10 diagram of the copper diagram. Sorry about that. Here you can see again this is the lead 10 system, and this is that maybe the composition not as around. We see that here is the liquid region again. So this is the liquid alpha. So the liquid region and the alpha phase going in. Now it is completely transformed into the alpha. But now further cooling it down, may see some of the beta, these red spots are the beta phases that coming inside while cooling. Okay? Would be creating while cooling it down from 200 degrees in this region. Okay? At temperature beyond this point, okay, below this point, we'll be having some uh, beta phase particles inside the alpha phase. Okay? So now let's discuss this as a whole. This is again a lead-10 system. Electric composition as it is at around 61.9. It's not the copper silver system as we discussed earlier. This is another system. So for alloy composition, this is the electric composition. We're taking it over here. So here was the completely liquid system, liquid phase. You can see that there is no other phase, and while cooling it down this line, we see that there are two the structure is alternating of layers, which is called a lamellar structure of alternating layer, in which the bluer part is the alpha phase and the red part is the beta phase. And can calculate this composition of alpha and beta from the level group. Okay. So again, as we discussed in the previous video, part 1 of this diagram, if you divide this region completely by the total region, the total tie line, we will be getting the composition of the beta phase, and if you divide the red part with the total length of the tie line, we'll be getting the composition of the alpha. Okay, so this is the compositional or the microstructural changes in practical say in a eutectic composition. Now we'll be discussing the microstructures from this region. Before that, you can see that there are this is a microgram of the third plane, eutectic microstructure. That LAMELLAR inter alternating layers of the alpha and the beta. again, this is the micrograph, the micrograph, which you can also see book of characters and beta is usually of the lead and alpha is the 10, but not almost lead and 10, but not all. Okay, so microstructural developments in electric systems 4. Alloys of which 18.38% of 10 is less than this composition and greater than this composition. There's alpha particles. Okay, so let's see this. Now we are discussing hypoeutectic system. Okay, so this is the liquid phase. While we will be cooling it, it get put on alpha over the liquid line. Then these particles will be going, and on further cooling, see that this primarily formed alpha would remain in that, and on further cooling from the liquid plus alpha region to the alpha plus beta region, you may see that the lamellars or the alternating layers of alpha beta form are being formed as well. So this part is called the primary alpha, or you can say the pro-eutectic alpha region. Okay? Because this region was formed earlier in this liquid plus alpha region. So this would remain. This is called pro-eutectic alpha region, or the primary eutectic region. Okay. So now, as I was discussing, hypo and hyper-eutectic, that. So this is the hypo and hyper-eutectic site in which the left region of the eutectic line is the hypoeutectic system, and the right region on the eutectic line is the hypereutectic. So you can see these diagrams that in this figure, this micrograph, you can see that there are the darker spots, the dark black spots are the pro-eutectic or primary eutectic alpha has been formed due to this liquid plus alpha region. And due to this liquid plus beta region, this beta, primary beta region, that is pro-eutectic beta phase is being present over here. And if you visualize this eutectic composition, so you won't be getting any of the primary eutectic alpha or beta phases in this micrograph, because the liquid is directly converting into alpha and beta, and these are the alternating layers. Again, these darker spots are the primary eutectic or pro-eutectic alpha regions, and the darker lines in the red, the whiter, the grayish lines are alpha and beta in alternating layers. Similarly, these gray spots are beta, which are primary eutectic beta phase, or we can say pro-eutectic beta phase, and the other dark and gray, dark black and gray lines are the alternate phases of alpha.